Hello, everyone, and welcome to the 11th edition of Tiny Talks. Tiny Talks is a place where Rocket alums share real world learnings from their day to day work. And we have Kushal with us here today. This is Kushal's second Tiny Talk, so I'm super excited to see that. And he's going to talk about how to handle scale using load balancers. So, when we are shipping anything on the front end side of things, uh, that runs on your client side itself. So maybe it's a browser or anything else that is easy to scale because it's all the compute resources are on the client side itself. But how do you handle the API calls traffic, the backend traffic across servers to enhance the performance and scalability? That's what Kushal is going to talk about today. So over to you, Kushal.
Yeah, hi everyone. I hope you are well. Enjoying the Sunday morning. Interrupted by me. Yeah, I'll just start sharing my screen first and see if the internet connection is stable. Uh, how do I do it? Desktop one share. Just let me know if there's a frame delay or something. If not, I can proceed. Anyone finding any frame delay here?
No, everything's good.
Okay, great. So we'll start. So this is today's topic. Hi everyone. We'll be handling about uh, how to scale using the load balancer. So first of all, let me introduce myself. I'm Khushal Sharma. I work in Strand Life Sciences. I like to travel, hike mountains, and reading books. I'm on the social by this username. So if anyone want to connect, say there. So let's look at the problem of today, what we're going to discuss. Let us say your current situation is you have a simple to-do application and your average traffic and your visitors, number of visitors are 1,000 visitors per day. So you have built an application, it is under production, and you are getting 1,000 visitors per day. It's a good enough application, right? Now, let's just say someone, your famous Instagram or TikTok influencer, find your app and found that it is so cool. So they made a reel or post about it, and it becomes viral. Now, due to this thing, you are getting a spike in traffic. You are getting 1 million requests per second, 1 million API requests. And that's a very large amount of request. The question is, how do you handle your existing application? Because if your average traffic is 1,000 visitors per day, you must have taken the similar amount of memory or RAM to handle 1,000 visitors, right? But somehow visitors increase to 1 million. Now your server aren't expected to get this much request, right? So they'll get overwhelmed and most likely break in the production. So the question is, if this situation arises again, how will you handle the influx of users without doing any downtime? So let's look at the solution. There are two kinds of solution. Uh, as you have heard the term distributed system. So these are kind of solutions using distributed system. What are distributed system? They're just uh, system which help us to scale the user traffic, right? Now let's look at the approaches using distributed system. We have two approaches. First is scaling up, and second is scaling down. Uh, we'll look at the vertical scaling, which is also called as scaling up. In the vertical scaling, what we do is we have a server, right? We have a server on the backend server. What we can do is, let's just say out instead of 1,000 users, we are getting 1 million requests per time. So what we'll see is our RAM and CPU utilizations are all-time high. So what we can do is we can increase the RAM and CPU hardware. So vertical scaling is mostly about hardware and how can we increase the hardware to handle more requests, basically. So it has some advantages that it is very simple. We just have to increase the hardware and you don't need to change in application architecture. right? But it has some disadvantages because hardware is costly. So uh, as hardware is costly, you will increase of all total software will increase, and there's a limit to how much you can increase the RAM. So you cannot just indefinitely keep increasing the RAM, right? So that is a physical limit on that thing, that your system or your machine should support. Let's just say you have 16 GB RAM and your system only supports increasing the RAM up to 1 TB. You cannot go more than that, right? So if there's a point of failure where like we can not increase more than that particular limit, the server will fail. So this is one condition. Let's just say there's some downtime or bug in your code. And if your server fails, your application goes down. Another thing is if your server can handle 1 million requests. So if the server is broken down, you won't be, other the users, the new users coming to website won't be able to see anything. Their request, API request will get failed. And this is called a single point of failure. Instead of this thing, if you had multiple servers, the users would have seen all the requests going to the that server instead of the primary server. So here's an example scenario, which is upgrading your 16 GB RAM to 64 GB RAM. So we are increasing the hardware here, right? Instead of RAM, there can be CPU architecture, the processors. If you have looked at the CPU utilization, right? So let me give you an example first here. So this is what my CPU utilizations are currently. And if you look at CPU percentage, right? And this Zoom client is taking 90% of my CPU right now. So if similar things are happening and your server and requests are coming too much and your CPU iteration is already taken. I have in my system, you can see I have 8 core processor and all of the cores are not fulfilled exactly, right? So some are at 15%, some are at 12%, something like that. So in case of increasing the CPU, we can increase the cores, number of cores, number of processors, etc. Right? Let's look at the other solution, which is scaling out. So instead of scaling up, which is building on top of your existing server, what we can do is here in the horizontal scaling, we make the replica of your server. So uh, let's just say you have made an scaling up solution, which is like instead of 16 GB RAM, you assume that you can get 1 million requests anytime. So you increase the RAM to 64 GB. But now the system is still failing. What you can do is you can do horizontal scaling. So we'll make a replica of your existing server and distribute the incoming requests across the multiple machines. So the advantages of this thing is it will be easier to manage the high traffic and there's no single point of failure. So even if one server goes down, the other servers can handle the request, right? There's some disadvantages. That is, it needs a change in architecture of the application and it's a bit difficult to maintain. We'll see on the complexity part, but yeah. So here's an example scenario that you are deploying multiple server and distributing traffic. We'll see detailed example of this thing. Let's look at the potential solution using scaling out, right? Uh, this is an example without load balancing. So you have 1 million requests coming on the user and sorry, 1 million requests coming on the server and it is overloaded. So what happen is it will get failed and broken down. So these all clients will get error or slow response time, right? So with the load balancing, what will happen is we'll add a new component in between that thing, right? If you can see, all the users are going to this component and then going to the request to server. So this component is called as load balancing, and this component is just in another server, right? In production, you will see something like Nginx server. In example here, we'll use the normal JavaScript HTTP server. So I just wanted to let you know that in the production apps, there's no just one thing. So we have looked at two solutions, right? Horizontal and vertical scaling. But in production, what will happen is a combination of those two. Like you will try to increase your RAM to as much as you can. Like let's just say you had 16 GB RAM. You will increase it to 64 GB RAM But then further, you know that there's a limit to it, and you need to make a replica of it. So you will find a mixture of those two solutions. So let's look at the load balancing. What is the load balancing? Load balancing is distributing traffic across incoming traffic across multiple servers. As we have seen the last image, if the multiple traffic are coming, it will go to one server and it will distribute the request among the multiple servers available to us. And the advantages of it is that we can use the efficient solution, which is we can know the server traffic and handling it is. Then based on that, we can maximize the resource utilization. Performance, obviously, if we are if we are able to give the response faster and giving less time for each task, then the performance will increase, right? The API call will take less latency and the response to the front end will be faster. Reliability, as we discussed in the scaling out solution, the reliability is because there's no single point of failure in this case. So we'll have a reliable solution because if the one server goes down, we have remaining servers, right? So how does it work? There are two kinds of things technically. We'll give the list of servers to it, and based on that thing, what it'll do is it monitors the server health. So basically, it will look at this stop command, right? Let's just say I told you the stop command. It has CPU percentage, RAM percentage, it has the core utilization, right? So based on that thing, it will look at each server and look at its health of the server. So if the server is used too much or it is computing a heavy task, so that processor will be or the CPU will be utilized too much, right? So it will send less request to that particular system. And if the CPU or system is free, relatively free, it will give more requests. That how dynamic load balancing work. Also based on the traffic. So if there's too much traffic, we'll have to distribute among multiple servers. We can we can increase the server capacity. We can make a new replica based on those things. So let's look at the demo now. Mm. Sorry. Okay, in this code here, look on this side. We have non-modules folder, git ignore, and this some script, right? Let's just go to packages. I have two packages installed here. You can forget the non one. We don't need it. We have express and not fetch. In the most case, we can just use the express. Okay, and we are starting the server.js. So let's go to server.js first. So this is my backend server, and this is a sample to-do application which I'm just doing get to-dos and post to-dos. There's nothing else. These are the only two parts. Okay, so let's go to it line by line. We are just importing the express here. We are importing the body parser. Body parser is used to parse the body of the data, right? Like when we are getting the post object. So we need to pass the JSON body from it. That's when the body parser is getting used. So next thing is share data. So we are importing the code of this share data file. So we'll go through it a bit later. Right now, let's go for next line. So next line is initializing the Express app, and we're declaring the port, right? Next line is we are making a variable named as server ID. Server ID is just an random string, right? So that we can uniquely identify this thing. This is fine. We are using this consoling the server name and handling which kind of request get or post and the URL of the request. So basically slash to do or post slash to do. It can be multiple routes, right? So that's why we have here two routes here. This is get and post, and these are kind of self-explanatory. On the get to-dos, we are using getting the all the to-dos we have created. And then the post to-dos, we are creating new to-do object and passing it to add to-do function. So if you can see here, we have code name as share data.get to-dos. And here is share data.add to-dos, right? So we'll go through this code now. Let's go to share data function, share data file. Here we have, for the sample project, we just have an empty array. This is my database. And I have initialized some methods here, get to dos and add to dos and update to dos. Update to dos I'm not using it, but yeah, those two first functions I'm using in the server.js file. Right? It will just add the data to array or and get all the data from it. That's two things. Yeah. So this is our server, backend server. Let's look at the load balancer file. How this load balancer file looks, right? If you look at load balancer file, we are instead of Express server in this file, I'm just using HTTP server. So Express is based on the HTTP server, and we can just implement the solution using Express, but yeah, we'll just go for raw thing now. So I'm importing the HTTP server here. I'm importing the URL thing here. Nextly, I'm defining the servers, array of servers, right? So this is where I'm hard coding the thing, but it is not necessary to hard code. If the advanced solutions using Nginx and other things, they can automatically identify the servers available. So we might not need to hard code the servers available, right? And this thing can change. So when you run, this might change based on your env files. So keep this in mind. So I'm initializing another variable current server 0 to keep track of index. Now let's ignore this function and let's go to this line. So this line says a variable named load balancer, and we are doing create server method of the HTTP package and passing this request, right? So let's go to the function now. In the function, what we are doing is we are creating a server URLs. So basically, based on this index, we are selecting a server from here and increasing the index. So we are using the round robin method for selection of the next server for the next request. So let's just say we have three servers, right? And if you want to go to first request, let's go to first server, and then second request, let's take it to the second server. So this is how we are doing. So this is called as round robin method for distributing the request. Next thing is we are just consoling the where we are sending the request to and parsing the server URL from here and making options to send it to basically HTTP request, right? And just appending this options and requests to this particular server. So let's go through this code again after running this file. So let me just try to run this thing. I have to go here. Copy relative path. Okay. 3D space. Copy path. Okay, I'm inside the thing. I don't know if you can see my screen or not, but yeah, let me zoom in a bit. So this is load balancer file, and firstly we'll start the server, right? So we'll start the backend server. This is the code for it. This is a command for it. So what I'm doing here is I'm writing port number and then I'm running the node server, right? Node space server.js file. So server.js file is Express server. That's what we are starting right now. So what this command does is this is a Linux thing, Linux and Mac thing. It might not work on Windows. So I'm just adding the port here, env.port, right? So I'm just setting an environment here and making the port to 8001. You can just write it as simply as export port equal to 8001, and then next line you can write node space server dot js. So this is the same command, or you can write as the other way I showed you. Sorry. We'll just open the new tab here. Okay, let's not do that. We'll open a new terminal. Open a new terminal and run another server, which is Which should be done. Okay, sorry. Yeah. And we'll run this thing using the same command, which is port. We'll start the server on 8002. Right. Similarly, we do uh, one more thing, which is on the port number 8003. So right now what we have is we have three servers which are running on port 8001, 8002, and 8003. Okay. Next, what we'll do is we'll just run the load balancer. So node space load balance.js, right? Okay, I'm not in the directory. Sorry. Node space load balance.js. Yeah. So load balancer is running on port 8000. So let's look at things again. We have server 8001, 8002, and server on 8001, 2, and 3, and load balancer on port number 8000. So what we'll do is we'll send any request. Let's just say get to do's or post to do's on port number 8000, and it will redistribute the request to 8001, 2, or 3. So let's open the postman and try to send a request. Yeah. So this is the URL localhost 8000 and slash to do's, right? So I'm doing a get request on route slash to do's. I send a request. I'm getting an empty because there's no data there. Let's look at the load balancer now. This is load balancer. It got request and it is forwarding to the server 8001. So let's go to 8001. It says it got the request, get request on this particular endpoint. So uh, instead of making this one by one, I have just an similar request script, which is just doing an basically fetch request to the this particular route, and I have given a number of requests, and it is running a for loop. So it is running a for loop of number of requests, and it will just use the delay given, and based on that, it will just do fetch request to endpoint. So let's run this file. I'll run this file using node space simulate request.js, right? So it has sent all the requests and the status code of all the requests is 200, right? Let's go to load balancer now. So this is our load balancer and it got 200 requests and it is forwarding to different servers this time. If you look at the first request was 8001, second was 2, 3, similarly. This is how we are distributing the request. Uh, uh, let's go to the servers. So some request got on 8001, few on the 8002, and similarly on 8003 as well, right? So we are able to make the load balancer successfully. Yeah. So now let me try to explain this load balancer file once again. So we are using HTTP library to do the make the HTTP server and send the request. So this load balancer will work as a middleman. Any request we are getting on port 8000 will be distributed between this thing, and the sending and distributing request will be done by load balancer. So what we are doing in this function is we are just making selecting a particular server and sending a request to that server, and whatever the response we are getting from the 8001, 2, or 3 server, we are forwarding back to the client. And this is what we are doing here, right? Uh, Let me turn off the one of the server. Let's just say we turn off the 8002, right? I have closed the server and load balancer is running. Yeah, load balancer is running fine, and one is running fine, and two is running fine, right? So let's look at this thing. So what is this? It is response giving me the response to the client, right? We are just getting the URL and sending the request and giving the response back to the client. So how does this work? Even if one of our services go down, or as we said, the single point of failure, right? So load balancer doesn't have single point of failure, or the uh, scaling. Uh, Sorry, I forgot the name. Scaling out solution doesn't have the single point of failure, right? So we have 8002 server, which is down, and we'll try to simulate the request now. We'll send the request, and we'll see that, okay, load balancer failed. Wait. Okay, load balancer is running now. Okay, so socket hanger. So if you look at response status 1, we are getting 200. Let's look at this one. What is happening? Okay. So now it tried to request forward the request to 8001. It went successful, and it tried to handle the request to the second server, which is 8002. I didn't handle it correctly, so it stopped the load balancer. But the logic was, if this is working fine, it will ignore the 8002 server and return the response request status to back to me. So it will be 500 error status code, and other requests should be working fine, right? Sorry for that. I was not expecting this thing. But yeah, let's look at the next slide. So now that we have learned the load balancing, the question is our scaling challenges fully addressed? Even if you have a single point of failure implemented and you can manage the 1 million requests per second, the question is, you'll have a database, you'll have an caching layer. All these things are still there, right? Even if you have a multiple servers like this, we'll need a centralized database system, because if all servers have different database system, it won't work out, because they need to communicate, right? So they need to be centralized database system as well. So the question is, if you have build a load balancer, will your server be able to write 1 million database writes per second? Let's just say I send a post request and your database is something like MongoDB. Will you be able to write 1 million database requests per second? Might not be true, right? So also this thing called queue systems, if you have heard of Redis, RabbitMQ, etc., right? And caching layer. So this is the thing we should explore more. And yeah, uh, let me give you introduction to queue systems. So what queue system does is, let's just say we have 1 million per second and our system is failing. So in case of that, what will happen is, we'll make a queue of the requests coming to us, and we'll write one by one. We cannot make a let's just say our database server has a capability of 1,000 requests per second. It cannot handle more than that. So what we'll do is, we'll make a batches of 1,000 and give it to the database. So any new request coming to our database write, what we'll do is, we'll just queue it up to 1,000 requests per second, 1,000 writes, and give it to database. So this is how queue system works. So if you have heard of Apache Kafka or RabbitMQ, these are the queue system examples. Caching layers is again if you have multiple DB reads, right? So let's just say you are working on something called a Geo Cinema, right? So they need lot of viewers. They have a lot of viewers when the IPL or cricket matches happens, right? So what they need to do is they need to do caching on reads because each reads costs us as well, and they have too many users. So if the reads are very frequent and common, we can do is we can cache the reads so that the response time is faster. So these things need to be learned after the load balancing. Yeah, that's it from my side. Feel free to ask questions. The code repository, I'll give it to the I'll give it in the slide. Oh, okay, I have already added in the reference slide. This is the first, and I'll add the just a second. Yeah, I'll add it to the slides. I'll add here in the readme. So do let me know if you have any questions. I'll stop sharing. Okay, yeah, they just go. Oh, it's a clap. Sorry.
Um, nice presentation.
Thank you, Tejas. We are sending request to one by one to one request to server, but how it will maintain any server fails and how center server will distribute the request will work. Can you explain the working of it? Yeah, so Ravi, I tried to do that, but it failed. So maybe we can, I can what give you as I can give you section on this README, and it will tell you step by step the solution for that. Okay, or you can connect with me on any socials. We can discuss in one-to-one meeting. So basically, what will happen is if one of the server goes down, let's just say we have three servers. The server number two goes down. The one and three are still working. So so it will distribute the network to one and three instead of two. Uh, any other questions? No.
Not a
Yeah.
question, but I found this visualization I shared in the chat. It might help people to understand what's happening.
Okay. Yeah, this is a good relation. I'll just add it to references so that people can use this thing. So as I said before, in the real-time system or production system, this Express server or load balancer server of the HTTP server will be replaced by Nginx. Or if you are using the cloud services, they may have in-house solutions for these things. And there's no such thing as just one horizontal or vertical scaling. Always there's always a mixture of both. We'll try to expand the RAM and CPU as much as we can, but up till the limit, right? And then we'll make the replica of the servers so that we don't have a problem with one thing as well as we can replicate the things. Because let's just say tomorrow you have today you have 1,000 requests per day, and tomorrow it goes to 1 million. But now you don't know how much time will be, or maybe the day after tomorrow it goes again back to 1,000. So we will have to uh, keep adding and deleting the multiple replicas, right? So the optimal solution is mix vertical and horizontal solution and find the perfect threshold for your thing. And as you go on, let's just say if you're in the cloud services, AWS or something, they do also give you option of auto replicating the thing. So they look at your number of requests and keep a buffer. Let's just say you are getting the 80,000 requests and yeah, you and the server needs server has a capacity of 100K requests. So they'll try to add a replica on 80,000 request only, so that you can, if the user load increases up to 120K, you will be able to handle. So this is how auto scaling works in the cloud providers. Anything from users? I guess that's it. Swapnil.
Cool. All right. I think when there are less questions, either there is one of two things. Either everyone understood everything or everything went above the head. And I think I am pretty confident it's the former because uh, you had a live demo. Visualizing things makes it pretty easy to understand. So yeah, I think pretty amazing talk. And thank you everyone else for taking out the time to join us on a Sunday morning. Feel free to connect with Kushal on his socials. Can you, Kushal, can you share your handle as well in the chat? Feel free to tag
Sure,
him.
sure.
And yeah, the best way I'll drop an email as well with the uh, GitHub links and everything. And
Yeah, much better idea. Yeah.
yeah, the what I would highly recommend before we have, not before, just take an assignment today itself. If you really want to internalize the learnings, spend 1 hour, 2 hours this Sunday, which is today, and create a simple load balancer of your own, because that's the best way to learn things. Otherwise, what happens is you know things in theory because you have seen someone deliver or talk about it, but if you haven't implemented it yourself, you haven't seen it running with your on your machine, basically, it's hard to internalize a few things. So um, try it out yourself, get your hands dirty. You'll run into a few issues, then you'll search for it, then you will uh, discover something new. So yeah, that's about it, folks, and we'll wrap this up
Yeah, I
today.
agree with that thing, because what happens is, for me, just too many big complex jargons, right? So you'll have to learn Nginx, you have to run Redis, you have to run RabbitMQ, etc. So my friend suggested me that just forget all this. Tell the ChatGPT or Claude to make a very simple to-do application and don't use any of those tools. Make things in what you know. That's become a bit easier to learn. So you
Yeah.
can try this.
Yeah. So the concepts are more important. Once you know कि
Mhm.
हाँ इस problem में you should be using a solution like a load balancer, then what is the actual implementation that you are going to use? That is something that is Googleable. That is something that you
Hmm.
can ask around. But what to use exactly in which problem? This is something that, if like the more you know of these things, the better you're sort of uh, like well placed in your career. Cool. On that note, we will end this session here. Thanks for joining in, and thank you, Kushal, for delivering a great talk. I'm super happy to see this. And all right, cool, folks. Have a great rest of the Sunday. See you next time. Bye bye.
Bye
Thanks.
bye.
Bye bye.
Thank you.